Okay, I'm guessing because we're moving on, you understand examples 3 and 4. We're going to put it all together with, again, some added stuff. So example 5, if you want to maybe highlight this, circle it, star it, something. These right here are kind of your steps when you are solving these. So the first thing you want to do when you are factoring or solving is you want to list out all of your possible rational zeros. You do that by this right here. You're going to figure out your P over Q. Then you want to use your graph, and we are going to use our calculator graph to eliminate some of these possible zeros that we found in part A. Okay, it's going to help us kind of zone in on what our possible zeros are. So then in C, we're going to actually find our rational zeros. And then on D, we're going to factor, or that would be factor and solve. So let's list all of our possible rational zeros. We will do this by listing our P over Q. Now with this one, you could still list all of your P over Q. But notice here that my P is 20. Okay, and I'm just going to put negative 20. My Q is 1. And I'm just going to actually not put negative 20. Let's just keep this as P. Okay. If your Q is 1, then this is just going to be P, right? If I have negative 20, like I had over 1, that's negative 20. If this was 50, and I had 50 over 1, then this is 50. So when your Q is 1, when I'm listing this, all I really need to list is my P. Okay. And so my P here is 20. So this is going to be plus or minus 1 and plus or minus 2. 3 doesn't go in, plus or minus 4, plus or minus 5, 6, 7, 8, 9 don't go in, but plus or minus 10, and then will be plus or minus 20. So 1 times 20, 2 times 10, and 4 times 5. So list all of the possible rational zeros. These are my possible rational zeros. And again, on this one, all I care about is P because Q is 1. So when I divide everything by 1, it's not going to change. So now let's use our graph to eliminate some of our zeros. Okay. So I'm going to go over here to y equals, and I'm going to enter this in. So x cubed, where's my equation? Plus 8x squared plus 11x minus 20. Now, a lot of times we go to zoom standard, but I don't want standard because I could have values as big as 20 on here. So I'm going to go over here to window, which it is already on standard. And I need to change specifically my x to negative 20 to 20. And now I'm going to hit graph. Because my biggest and my smallest possible rational zero is plus or minus 20, I need to be able to see that on my graph. So I'm going to hit graph. And there's my graph. Now, it's got an x cubed, so I know there's a possible of 3, and it does look like it crosses 1, 2, 3 times. Now, when I'm looking at this graph, I can eliminate plus or minus 20 because that would be right here on the edge, and it's nowhere close to the edge. I can also go ahead and eliminate plus or minus 10 because 10 would be about halfway. And negative 10 would be about halfway, and it's not there. So use the graph to eliminate some possible answers. I can eliminate plus and minus 10 and plus or minus 20. So now that I have eliminated those, now I can kind of zero in and get smaller on my graph. So I'm going to go back to window. After 10, the next smallest thing it could be is 5. I'm going to change this to -5 and 5. And so here's my graph now. Now with this one, I can see all of my zeros. I can see I've got one here at 5, at 4, and at 1. Now, if you can't tell, which really you can't tell that these are perfect, I'm going to hit trace. And I'm going to enter in -5, and I get a y of 0. I'm going to punch in -4. I also get a y of 0. I'm going to punch in -1, and I get y of 0. So from my calculator, I can see that my zeros are -5, -4, and 1. This is rarely going to happen when you have whole numbers on your calculator here. So just so that we can understand the process, we're going to pretend that we could only tell that this first one here, -5, was my 0. If I can only see one of my zeros, now I'm going to take this, and just like we did on example 3, I'm going to take that 1 0 that I can see. I'm going to factor it out using synthetic division. Once I get to a squared, then I can factor. So let's divide this out. So -5 on the outside. And I have 1, 8, 11, and -20. It doesn't skip. It goes x squared, x cubed, x squared, x constant. So I don't need to put any zeros. So we've got 1, 8, 11, and -20. I'm writing my coefficients from here. Use synthetic. Bring this down. Multiply, add, repeat. Multiply, add. Multiply, add. Multiply. And when I add, I get a remainder of 0. So this is my constant, my x squared. So we get x squared plus 3x minus 4. Now that I'm down to a squared, now I can factor. So my a times c is 1 times -4. My b term is 3. What adds up to 3 and multiplies to -4? And that would be 4 and -1. 4 times -1 gets me -4. When I add, I get to a +3. This one, luckily, is an easy trinomial. This is its factor. This is x plus 4, which that's that 0, right? When you subtract it over, you get x equals -4. And x minus 1, which is also this 0. When you add your 1 over, you get x equals 1. So now when I factor, and I'm out of room, but you should have room down here, but I'm out of room, so I'm going to bring this over here. So now I factor this. If I wanted my zeros would be -5, -4, and 1, but I don't want zeros. I want this in factored form. So this as a factor is x plus 5. And then these are already in factored form, x plus 4, x minus 1. So we have now taken this cubic function and factored it out. And again, because it's an x cubed, I have 1, 2, 3 factors here. Okay, let's do this again. Now on the next problem, I don't have these as my steps. It doesn't walk me through it, but these are my steps. Find the possible rational functions, figure out what you can eliminate, find your zeros, part of them from the calculator, part of them from factoring, quadratic formula, square root property, and then either write this in factored form or take it a step further and solve. So, use the rational zeros theorem along with the graph to find the possible real zeros of the polynomial, find the remaining irrational zeros, and factor the polynomial over the real numbers. Okay. So, step 1 is to find your possible rational zeros. It helps when you're looking at that graph. Okay. So I need to do my P over Q really quickly. And because my Q is 1, I really just need to list my P. So P is 46. So to get to 46, you can do 1 times 46 and 2 times 23, and that's it. Okay, so now let's go to the calculator and figure out if I can eliminate anything. So we have x cubed minus 2x squared minus 23x plus 43. Okay, I'm going to come over here to window. I really don't care about these y's. I'm not looking for the max and the min of my graph. I want to know where are my zeros. I know this could be as small as negative 46 and as big as positive 46. So that's what I'm going to make these right here. You can change your scale if you want. It doesn't really matter. I'll go 5, just so there's not as many little tick marks, but it doesn't matter. So let's graph. Okay, here's my graph. Can I eliminate anything? Okay, well, I hope you say we can eliminate 46 because we got negative 46 here, positive 46 here, and it's nowhere close to the edge of this graph. 23 would be about halfway. I'm nowhere close to that either, so I can eliminate 23 as well. So now I'm going to zoom in, and because it's 1 and 2, I'm actually going to go to a window of 3, just so it's not so crammed. I'm going to go back to a scale of 1. And so here's my graph. Actually, let's go out a little bit more. Okay, and I'm going to go out just a little bit more than that. Okay, so here's my graph. And it's a cubed, right? So I know that I could have as many as 3 zeros, and that's what I have. I've got 1, 2, and 3. My only possible rational ones left is negative 1, 1, and negative 2, 2. And I can see from this graph, negative 2, there's nothing there. Negative 1, there's nothing there. 1, there's nothing there. Possibly at 2. So when I go to trace 2, I get a 0. You can see in this one, it's in between tick marks. Same way on this one, it's in between tick marks. These are some irrational zeros. So the only rational one I have is right here at 2. So a possible zero from the graph is x equals 2. Thus, the factor should be x minus 2. So B wants me to use long division to find the reduced polynomial and then find the remaining zeros. You can follow directions and use long division, but I will be using synthetic since this is in the right form. So my 2 will go outside. And then it's not skipping anything. You got x cubed, x squared, x, and 46. So I'll just put in the coefficients. We've got 1, -2, -23, and 46. Bring down your first one. Multiply, add, repeat. Multiply 2, add 0, multiply 0, add -23, multiply for -46, add 0. So that remainder tells me that this is not just a possible 0, that is a 0. And so what do we have left from here? Well, this is your constant, your x, and your x squared. So I have x squared minus 23. Now with this one, this isn't a perfect square, so I can't use the difference of squares here. So if I turn this into an equation, then I can solve. I just said I can't solve by factoring because this isn't a square, a perfect square. So I've got quadratic formula or I've got the square root property. Which one do you think we should use? Because I have no b term, no x, this one's really easy by the square root property. Get your square term by itself, and we'll do that by adding over 23. The opposite of squaring is to take the square root. So square and square root cancel, so I'm just left with x here. And then remember, this isn't just the square root of 23, this is plus or minus the square root of 23. So when I find it says use the real zeros, which this is a 0, this is a 0, to factor. When you're factoring, you want this in parentheses. So the first factor is this x minus 2 that we found. And then I have x plus the square root of 23 and x minus the square root of 23. And so now I have taken this and I have found it in its factored form. So remember, when I find this right here, this is called rational zeros theorem. Because the square root of 23 is irrational, it's not making this list. Okay, so this list only helps me with rational numbers. When you get square roots, those aren't going to be listed here. And you can keep your graph up and still check these answers. Okay, I still have trace on. So if I put in the square root of 23, I get y is 0. So that was right. If I put in the negative square root of 23, we also get 0. So we can use this graph to check.